Some good marks here. First of all, is known as the 5 basic assumptions of something known as the kinetic theory of ideal gas. So there are 5 basic assumptions for gas to be what we call ideal. All right, you have learned all this from your school. Gas, there are 2 types. It's called real gas versus ideal gas. All right, in reality, there's no such thing as ideal gas. Okay, which we'll take a look in a short while. All gases are real. But when we want to discuss some concepts, all right, we will have to treat them as ideal in order to discuss. So what are the 5 basic assumptions to assume that all gases are ideal? These are the 5. In case nobody tell you before, these are your free marks. Usually, they will not come out all 5. They will ask you for 2 assumptions, 2 to 3. Okay? And over here, there are 2 that is more important than the rest. Okay? So here we go. First assumption. Are the gases consist of particles that have negligible volume or size? Obviously, you can memorize this. Right? But that's not my concern. Okay? We want to look at those that can play. Number 2. Gas particles have negligible intermolecular forces of attraction. So this is linked to your chem bonding. And if you ask me, these are the 2 most important assumptions. That's why it's my top 2, which we'll discuss again later. Third, gas particles are in continuous random motion. What do you mean by continuous random motion? Meaning they collide occasionally with each other, as well as the walls of the container. So basically, if it's in the Bishan Center right now, we have a couple of students with me, it means that you and me are always moving. I can knock onto you. And at the same time, you will knock against my wall and bounce back. Okay? Now, why I'm running into this is a lot of y'all just like to memorize, and you find that, oh, it's damn long, then you start to do this. You full stop here. Which we never ask you to full stop. Correct? Got too long already, ma? So you say, okay, that's the keyword. My teacher also only underline. So this one not important. Wrong. Why? Because the MCQ come out, they don't talk about this, instead they talk about this. Are you with me? So you'll never be able to get an MCQ for the reason, because you're not specific enough. You don't understand, you're just memorizing. But if you understand, you don't even have to look at all these words. All right? So once again, they're always moving. Fourth, collisions between the gas particles are perfectly elastic. Once again, don't full stop there. What does it mean? It means there's no loss of kinetic energy when you hit each other. And we don't stick to each other at all. We just bounce off. That's the 4th assumption. 5th assumption is that the average kinetic energy of the particles in the gas is always constant. It's a fixed value at a constant temperature. In fact, the average kinetic energy is proportional to the absolute temperature. What is absolute? If you miss out, this is also wrong. Absolute means in Kelvin scale. All right? So there's degrees Celsius, there's Kelvin. All right? Which is very important because, ladies and gentlemen, in a while, you realize the whole topic, I will focus on this word called absolute temperature, in case nobody told you that. All right? If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.